Okay, good morning. Welcome by the second session of the Global EV Charging Test webinar on power quality and EV best practices. Good to see you again. We have this two-day event focusing on best practices in power quality, where the first day will be more on best practices by some parties active in the EV charging situation. And the second day will be more deep dive focusing on the power quality research that's going on in this field. All sessions will be recorded. You can watch them on YouTube afterwards. And also, it's still possible to register for other presentations as well. So please do. You can find the program on the website. So before we start, first we'd like to mention some practical matters. You can ask questions using the questions log in the program. It's a little drop-down menu you can click on. You can type the questions, and we will ask them afterwards to the presenters. Thijs will be looking to the questions in this session. I will be hosting the webinar, and the next session will be the other way around again. So we will switch positions. Furthermore, nice to mention that this webinar is made possible by the Progresses project, which is a large international project focusing on making the charging more efficient and more energy efficient by the next generation. So that's nice to mention. I think we are almost ready to start. I will give a little introduction. We have this second presentation by two people from Allego, Maarten Jaspers and Guillaume Goijen. Maarten has been involved in the EV market since quite a long time, 2011. He has been working on both technology of EV market, but also business models and system technologies. And Guillaume is at the moment working as product manager of the DC charging hardware at Allego, also very experienced in international products, ultra fast charging technologies, and at the moment focusing on the DC fast charging for electric mobility. So really looking forward to your presentation. I would say the floor is yours.
Okay. Thank you, Tim. Thank you very much, Tim. Thank you for the introduction. Thank you also for the opportunity for us to do the presentation. Do you now see my screen?
Yes.
I'm sharing now. Okay, good, because I do not see you anymore. So I hope it all works. So we are here, Guillaume and myself.
It's not out of presentation mode, please.
It's not in.
It's not a presentation.
Oh, it says here it is. Okay, now it is?
Yes, okay. Now it's fine. Thank you.
Okay, perfect. Thank you, Guillaume. It was all already there. Okay, good. So Guillaume and myself will be doing a presentation on the best practices. And we are from Allego, and as introduced by Tim already, I will do a little bit of the presentation, followed up by Guillaume. My current position is managing director in charging services solutions, and Guillaume is in my team as a product manager, DC charging solution. I have to say it correctly. And we have been working with Allego already quite a bit of years. I will bring you a small introduction of Allego, what we are about, what we have been doing, where we came from, based to that a little bit on a timeline, a little bit history. And I will go a little bit into the quality assessment process we have to make sure we have the right charging equipment in our portfolio. And then Guillaume will go into the best practices, the experiences on three defined topics: DC charging, the market, especially on the EVs, and then last but certainly not least, especially also related to the event, our best practices regarding power supply and grid. Introduction to Allego. We offer EV charging solutions, and we do that for home, work, and on the go. So highway sites, for example. And execution takes place in the project teams that are regional clustered. So here you can see the countries clustered with the corresponding colors that we call the regions. And in Arnhem, we have our main headquarters. There we have the team of where Guillaume and I are part of, the charging services and solutions. So we provide the solutions. We have the operation network, the finance, all those headquarter related activities are based in Arnhem, and the regions are really focusing on execution of the projects. We have offices in Berlin, London, Oslo, and Stockholm, and 2 locations in Germany, also Berlin and Düsseldorf. They are not as large as we are in Arnhem. And this is how Allego is organized. Not in all these colored countries we have chargers running yet, but it is the ambition to get there within a few years. Just as a small introduction to who Allego is. To build about that, some numbers. We started in 2013, we'll get to that later. And we manage our network, own charges. We do also do this for our clients. So they may have some charges themselves, and they are connected to our backend, and we operate and maintain them on their behalf. Currently, we have over 30,000 charge points, an uptime of 99.5%, meaning that nearly always you're capable of charging. We have 450,000 charging sessions per month, and this is growing. We use a lot of energy, 9.5 gigawatt hours per month. And to make things more related for today, we have today, as we speak, more than 1,000 DC and HPC units running in our network. And this is rapidly growing ever since. To give you a small impression of how an HPC site would look like, this is a site where you can see we have 4 HPC units and a DC system installed, so that we can support every EV that may need charging. And typically, these are the positions next to the highway, as you can see on the picture, with a gasoline station in the background. We are a CPO, and I will slightly go into it so that the whole information from Guillaume gets a little bit more into context. So what we typically do, we start with network planning after sales. So we can assume we may have a client with multiple locations, and then we have software algorithms developed ourselves in-house over the years based on our experience. And we can then make a prediction of future charging needs, so that we can actually define what charges would fit in what quantity of and what type of connectors to what location. And then we will typically do the investment, buying the equipment. We go on site, that's the hardware and realization services. We go on site, do the site survey, we apply for permits if needed, we apply for grid or power supplies. Then we have installers install the equipment, then we do the commissioning. So we work a lot with third parties. So we have a third party delivering hardware, we have a third party doing the installation service, etc. When we have the units commissioned, they will be connected to our backend, and then we will share the information throughout the regional channels, marketing, but specifically also via the apps and international platforms you may be familiar with, and people can actually start using the charges. We have access and payment services, enabling people to actually get access to the charges and have settlements in place. So we have roaming agreements with MSPs, but we have also direct payments features available with debit and credit cards, or direct payment via the app, or multiple things. We don't hope anything goes wrong, but if we can have on-site service with mechanics, all operated from Arnhem as a central overview, then we have additional services we're looking more and more into, smart charging and energy services related. So with smart charging, for example, we have been taking part of the Gelderland Overijssel tender and working with ElaadNL and the grid operator, for example, that we limit charging power in specific time moments, but we are now looking into the first pilots for DC stations as well. And with analytics, prediction and services, we are actually getting one more step further into sophisticated services, enabling ourselves to increase the amount of charges on the site before people actually ask for it. So we're trying to get one step ahead of things. So this is a snapshot of end of last year. obviously we have a lot of DC stations and AC stations. This is a DC related presentation, so I selected those. We have a market share of 17% for the Netherlands DC stations. As you can see here, in Belgium it's a little bit better, 39, and in Germany you have 10%. So although we do have quite a high number of charging locations, 80, 57, and in Germany even more than 300, we still have not that big of a market share. So you can actually see that the market is really growing really fast, but it is also getting more and more mature. Then a little bit about the history of Allego, maybe relevant. Also, maybe some of you know, we were founded in 2013, as introduced already by Tim. Before that, I was working at Alliander. Allego originated from Alliander. And we started out in 2013 with 13 people. We built our first DC network throughout the Netherlands, 50 kilowatt stations, because that was the technology of that time, especially for the Leaf and the first BMW i3s, etc. And that was finalized. So we had 50 DC stations together with Nemotion in the Netherlands and Belgium. Then we moved on internationally. So we had a Fast E project with the European subsidy and international partners, and we deployed over 300, again, 50 kilowatt stations throughout Belgium, Germany, Czech Republic, and Slovakia. Then the market demand grew for more location, but especially also more power. And back at the time, it looked a really good idea to start the ultra chargers. That was actually the development of the technology back then. And we started the project with international partners again, with countries as Belgium, Germany, and Austria. And we did a lot of work to build up the 350 kilowatt stations. And that was quite good. So we moved on to a higher scale and we built up the Mega E project so that we could build this HPC network into 20 countries. 300 and more locations will be deployed by Allego. That's not at the moment done yet. And last but not least, we also work together with partners. In this example, we work with Shell. We actually are contracted by them to actually build up and realize their network. It's fully branded Shell, but it's actually the Allego project. And today we do more and more. And all of these projects, as explained a little bit, actually are being operated and maintained as we speak up to today. And we are now looking into rebuilding them and upgrading them, etc., to keep on with market needs. A little bit about the FAT process for quality assessment, because this is the best practices presentation. How do we as Allego build up and operate a major DC HPC network? Well, we really need to have the best equipment possible. So what do? We have a stepped approach. We first come up with the schedule of requirements, a big document full of requirements based from Allego needs, but also coming from a lot of norms and grid related requirements, etc. We have put them all together. I mean, we have been doing this for years, so we have a large archive, and then we do an RFI, request for information in the market, and then a request for quotation process. So we get from the potential hardware suppliers to Allego, we actually get the information we may need. We select a few and we start the process. Then what we do, we go to the factory. FAT stands for Factory Acceptance Test. So with a group of specialists from Allego, we go actually to a hardware manufacturer factory and we do the full checklist on the equipment. First of hardware, components used, how it's assembled, stock control, etc. Installation related things like accessibility, safety measures. We do a lot of functionality testing, also how intuitive is the HMI, are there possibilities for branding. If that all looks good, we look into how do we maintain the charges in the field, by training, or spares or lead times. And last but certainly not least, we have also a keen eye on documentation. So do they actually comply to all the international norm standards? Because we do not validate all the tests, IP54, IK10, noise issues. I mean, we do have a short test cycle possible, but we do not redo all the things. So we do also request from all our suppliers a third-party independent reporting like TÜV or DEKRA, and we actually want these reports and we actually go through them to see if they actually do comply. And schematics, manuals, etc. for training purposes. And if this all is okay, and only if it's all okay, then we actually want to have the equipment itself. We typically bring it first to our lab here in Arnhem. We have a test work location, and we install the unit and we run it for a few weeks. We do a lot of testing. Then, if it all looks good, we bring it to an operational location, somewhere in the Netherlands, for example, where we have easy access. There is a redundancy of other charges, and we actually run it there for 1 month, 2 months, depending on performance. And if then all is still okay, contracting is all in place, training is done, etc., then the equipment is put up to the Allego portfolio, meaning that our complete organization can actually order it, install it, buy it, operate it, sell it, whatever. So this is how we are doing this. And what is the main takeaway here for this process? Well, it depends really on how keen the supplier is, but also what we find in the first steps, how fast the process runs. So around 3 to 6 months is really feasible and really common. Sometimes it runs even longer. What we learned over the years, and this is really something, testing with EVs is mandatory. Testing with test kits sounds easy, sounds convenient, but it is not the same thing as the real deal. What we also learned over the years, that although norm compliance is there, for example, the IEC norms, there may be differences per country. And since Allego is an international company, internationally focused, we need to be really keen on the country differences. And firmware development never ends. So we may have an FAT completely successful. There may be new features coming to the market, new demands, new cars, new updates, new norm, whatever. This is something we definitely need to keep an eye on, that the firmware development never ends. Okay, so this is a small introduction from my side on Allego and how the FAT quality assessment process runs. And now we move on to Guillaume.
All right. So we will move around in the room. Great. Hello, everybody. Thank you for the first slides, Maarten. I'm not sure well in the picture, but anyway, it's about the slides and the content, not about us. Maarten already indicated that, of course, DC charging is in development, where in 2013 it was sufficient to place one 50 kilowatt charger next to the highway to accommodate the vehicles that were present then. You see that there's quite a step change from that one single charger to a larger site, going from a low voltage grid connection all the way to a high voltage grid connection with our own transformer station, which is for us a totally different way of working. So the site is moving from one charger 50 kilowatt on low voltage grid to 300 to 350 kilowatt per high power charger max, multiple chargers on the high voltage grid. So, for example, if you look at a site which you recently built up in Germany, now we would have installed here a peak capacity of 750 kilowatts. Later in this presentation, I'll show that it's obviously a peak power. Apart from the chargers, as indicated in the back, you see a transformer housing where the actual grid connection is located. There are some interesting things about that as well. But first, in 2013, you had a 50 kilowatt triple charger, which was the standard. The triple charger means that there was an AC 43 kilowatt connector. There was Shademo, which is a Japanese originated standard for DC charging, and there was a CCS connected to the chargers. If you can look at the right graph, you see that the blue line indicating the CCS portion in our network until December 2020. You see that because of the newer vehicles coming to the market, mostly having CCS, you also see a rapid growth of the actual CCS charging sessions on our triple chargers in the network, which also showcases that it's not only a matter of enlarging your sites, going from a one charger to a larger grid connection and a higher power impact. So there's also potentially a higher impact on the energy grid, but also that there's a change in the actual protocol that is used, which allows for the communication between the charger and the vehicle. So higher powers are needed to support longer distance travel. An EV is already viable to travel from Barcelona to Stockholm. It takes a little bit longer if you need to charge on the way. However, the actual high power charging will come when the trucks and the buses will start charging, which will in the beginning charge continuously at 300 kilowatts, which is both a positive thing from a grid perspective and a negative thing from a grid perspective, because more power is needed on one side. At the same time, we noticed over the years that with each new vehicle introduction, on the previous slide, there was a Jaguar I-Pace shown, and one of the examples where then the marketing pushes the organization to launch a vehicle where they have been testing numerous times with various hardware manufacturers to check if the vehicle is actually able to charge. And then upon market launch, you see that there are also still older chargers with older firmware on the chargers available where then people cannot charge, because there's just a slight change in the protocol between the vehicle and the charger. So one of the takeaways at the end of this presentation will also be that maybe there will need to be a EU standard for EV or interoperability testing, and maybe a location where that could be done. But what is high power charging? The source of this graph is from a position paper of the Charin initiative, which is the platform behind the CCS protocol. Roughly speaking, high power charging, coined by them earlier this year, is going up from 150 kilowatts and more. So while speaking about DC charging, there are actually various steps, but high power charging is one of the things that you'll hear most about in the market. So first, we were having 50 kilowatt charging sites, and now we're going towards high power charging sites. If you actually look at that, what that means from a power curve perspective, on the charger side, you see here that the graph indicates the amperage and the voltage capability of the chargers. You see here the curve for fast charging ranging around 50 kilowatts. And then for high power charging, it's going all the way from 920 volts DC on the charging system, all the way down to around, let's say 300 volts. Overall, there are just many different voltages that a vehicle can charge, which also has an impact on how the charger operates and which what amount of power it takes from the grid. Parallel to that, stating that there is sort of high power charging, and there have been developments from in the equipment that provides that 150 kilowatt high power charging. Earlier, you had split units. So the first generation high power chargers, which we installed already as early as at least the test equipment in 2016, you saw that there were split units. There was a separate power module. We had the switch from alternating current to direct current. There was a link between the two, and then the vehicle could charge, the electric vehicle can charge on the dispenser or the kiosk, or how you want to name it. More recently, you see that there are sort of a second generation high power chargers available, which are standalone systems. There's a direct AC cable input, as well as there is a modularity in the power inside of the charger, which implies that if there's less power needed, for example, only 100 kilowatts, 50 kilowatts of power stack is not used in the charger. There are various different brands, and each have their own architecture in terms of stacks, sometimes 25, 30, 50, 75 kilowatt stacks. The earlier generation had one power block, which was then operating in a specific range. For example, a 50 kilowatt vehicle charging at a high power charger is operating in a less efficient spot of the AC-DC conversion than if it would be actually charging at its designed power. Over the next years, we expect, but that's our expectation, is that there will be a need for even larger locations with more chargers. Also, truck and buses will need to be charged at high power. We expect that there will be a DC grid solution, which implies that there will be one central power conversion and multiple outlets, which then jointly balance that max power available. But that's something for the future and maybe for our next presentation. So, earlier indicated, a high power charger is obviously not always operating at its max power. Allego sometimes applies for a 1 megawatt grid connection, but that 1 megawatt is not used all the time, every time. It's about the charging sessions that people will need at a specific moment when they need to travel from A to B and have a nearly empty battery. So if you look at a Porsche Taycan, for example, you see that the vehicle, the best spec vehicle, is marketed to be able to charge at 270 kilowatts. But if you look at the average that this vehicle can actually do, it's far less. And this is actually one of the faster charging vehicles on the market. And here, for the Taycan specific, you see that it can actually charge quite long at this higher powers. If you look at, for example, at the Tesla Model 3, the high performance version of the Tesla Model 3, it is marketed to be able to charge at 250 kilowatts. But actually, if you look at the average, it's only between brackets charging at an average of roughly 150 kilowatts. This also means that if you have a large site with a large grid connection, from a grid perspective, it does not mean that it will need this high power all the time. And also that the higher powers that are marketed in terms of what the vehicle can do or the charger can do are not the actual power that is consumed on the location. So all that information bundled, what does that mean for the power supply for our charging sites? There are many different procedures from a grid operator perspective. There are many different requirements or applied technologies in terms of protection of the grid on a European perspective. For example, if you apply for a grid connection in the UK, there is a default request for a report on the harmonics of a specific charger used. If you look at Germany, for example, there are specific grid operators requesting it, and then some are rejecting a specific charging solution, and others are accepting the same charging solution with the same harmonics report. So to us, it's still not 100% clear what the boundaries are for Germany on when a charging solution could be used and where not. For Belgium, for example, to be able to apply for a grid connection, you need to do a grid study, which is not focusing on the power quality, only on the available capacity on a specific location. There's no request for harmonic reports in Belgium. So from a power quality perspective, I think there's quite some stuff to develop on a European perspective. At the same time, what we also notice is that for almost all countries, the lead times for grid connections are increasing because of the demand for wind parks, charging stations, photovoltaic parks, and so forth. But we also see that within one country, there could be, from an operational grid connection cost perspective, quite big changes. So of course, if you have applied for a grid connection, you pay a certain fee to get the cable connected to your site. but on a monthly basis, you are also ought to pay for the max peak. In Germany, we have a few locations where we are only paying €2 per kilowatt if you reach a certain peak. For example, if you would reach 200 kilowatt max peak on a specific location, for the €2 case, you are paying €400. There are also locations where you actually pay a lot more per kilowatt. And that leads to a totally different business case, while you're actually providing as a charge point operator the same service to the end user, and people are expecting the same price. Lastly, on a European perspective, it's quite well organized, I think, in some parts of Europe. You see that the information to plan locations where we can build charging hardware is not always clear. I've had instances where the high voltage cable was actually at the other side of a highway. So that was quite complex to get the cable on the right side, as it's not always possible to install the chargers at a different spot because of the permitting and so forth. However, if you look at the listed items, one of the key messages I also want to express to this audience is that working closely together with a grid operator within their whole organization, so one central point of contact who can help with getting the right information about the grid, about the power quality, about the capacity for charge point operators can be rather helpful. We're now still at the beginning of the EV market. Rolling out 50 kilowatt chargers was already a challenge on some locations, especially next to the highway. Now with the high power charging locations, having 1 megawatt grid connections is becoming more complex. But imagine what if there are sites where you need to charge 20 trucks. What type of grid connection would we need? Would it even be possible to allocate that? Because, for example, the trucks are not as easy to maneuver around as the smaller passenger vehicles. And lastly, what we also notice already is that on a specific site, if you would request for a grid connection, is that the power is not present on all locations anymore. So we might have a contract where we want to place chargers. For example, for a specific case in the Netherlands, in a location near Zaltbommel, there was only 300 kilowatts present. So what we are then looking into is seeing if we can actually balance the chargers and then see for the first 2 years balancing those 300 kilowatts, and then hope that in the next 2 years other solutions are possible, for example, expanding the grid locally. As you can see on the right, on the image, we have already some extensive experience also with balancing 50 kilowatt charger with a refurbished battery solution. Already in 2016, we started such a project in Belgium, because on this specific location there was only 100 3-phase 100 amps available for 2 50 kilowatt chargers, which is far not enough. However, what we also see is that the cost of battery solutions, the permitting to actually place battery solutions, but also the speed that a battery can actually react to the curves needed for high power charging is not yet on par. So one of the things we could maybe jointly look at in the near future. So, as Maarten indicated, we are doing a lot of testing, obviously also from a qualitative point of view. The chargers that we operate also need to be easy to use from a wider range. EV market is going beyond the tech enthusiasts, which were joining the electric vehicle driving in 2011 already. So, Maarten, back to you.
Thank you, Guillaume. Yeah, so to summarize to some extent the key features, takeaways from this presentation that we would like to give you. What we see is a lot of development on technology, on processes, on norm developments, etc. But what would really help from a technology point of view is to keep moving to a single standard. Guillaume told us already that CHAdeMO is moving out. AC should be, to us, less applicable to HPC and DC sites. Moving to one plug is the most convenient for everyone, for charger builders, for maintenance, for operators, but also for the users, the e-drivers. Currently, this is a relevant discussion again because the market is moving to the CCS, but for the trucks, they want to have 1.5 megawatt charging. And there is a new discussion ongoing if we need to have a new plug in the market. Let's hope we can keep with the single one we are moving towards to. Also interesting is to learn from the fact that all new EVs coming to the market create a lot of functionality problems. So everybody says they comply to the norm, but eventually in real life situations, it does not always directly work. So what is interesting, or at least would be preferable, is to see if we can have a more organized new EV market entry, preferably on EU level. We're not working to that ourselves, but it may be something interesting to give a little bit of thought to. What we also see, and since Allego is an international oriented company, that we focus, or we work with a lot of companies, clients, parties, other stakeholders in the market, in the chain, that have a national focus. Well, transport, energy, nothing stops at the border. So network access, roaming is mandatory. Charging solutions should work not only in the Netherlands, but also in Denmark, and also in Poland, and also in Italy. Cars drive everywhere. It should always work. Same goes with power supplies and energy contracts and everything. We definitely, if we really want in Europe this EV market to bloom, we really need to focus internationally and not on a national level. There's really, in some locations, some areas, we run really into national-oriented focus ways. And last but not least is also the DSO role. As explained already by Guillaume, the power supply is the mandatory point for enabling EV charging, but it is not always available, it isn't always easy, etc. And there are also a lot of differences regarding norms, rulings, prices, etc. We also know that there is, to some extent, not always possible to supply the requested power supply. We are confident that smart charging is one of the solutions. We as a CPO, with the hardware suppliers, with the direct contact with the EV drivers, we can have a proper and reliable solution to meet EV driving needs, CPO needs, but also taking into consideration the DSO needs. I'm quite sure that we have, with the right cooperation incentive, we can make this work. So there is a bright future for EV in Europe. This was the end of the presentation. Thank you very much.
Okay, Maarten and Guillaume, thank you very much for your presentation. Very interesting to see what you're working on, the challenges that Allego faces, and also I think some very important takeaways. That there's still a lot of work to do, on international level as well, to really make a European-wide fast charging network. So thank you. We did receive some questions. The first one, I will combine some questions because we have quite a lot of them.
Good.
First one from Shamista. It's about the charger that is not always working at the full power level because the cars are not always charging at their full power. But what does that mean for the efficiency of the system and for the grid impact? Because the chargers will not be working on their most efficient power quality setting, also not the most efficient way of dealing with energy. So what's the impact of this?
You pick this one?
Yeah, I'll come closer to the mic.
Je let de piece dichterbij.
Actually, it's a good question. Interesting question also. Firstly, that information is not always present. So it's really difficult to understand before selecting chargers what their power efficiency is. It's always stated as a percentage in their best performing part. So what we tend to do is to actually measure then and what the actual performance is in terms of efficiency going from AC to DC. But then, especially if you would have, for example, a 150 kilowatt charger and then a 50 kilowatt vehicle would come to that charger, it's even less efficient. Of course, the end customer is not paying for that part. It's the charge point operator that has the burden of making the system as efficient as possible. But it's not only the charger, but it's also if you have a larger location with multiple chargers, it's also the transformer, which is potentially designed for 1 megawatt, which is only going from high voltage to low voltage at 50 kilowatts. So there's multiple components that create quite some inefficiency, and that's also why we are looking into requesting DC grid solutions where you have a more sort of DC balanced power supply to get rid of those inefficiencies. Also, what we actively do is now make sure that for example, the CHAdeMO standard is only present on the 50 kilowatt chargers on our sites, so that these vehicles using that standard are charging as efficient as possible.
Okay, thank you for your comment. And maybe, yeah, on this one, regarding DC grids or making chargers working on the DC grids, how will this impact the grid in this way? Because you will have different DC set points, of course, and the power you're taking from the AC grid is quite large. Is there a way to communicate it with the grid operator, or to maybe have some smart charging as well for DC fast chargers? What do you think about this?
What we are trying to do is to balance the power locally, so to have one set power for one whole site. For example, as the case of Zaltbommel, we have 300 kilowatts max on that location. We have multiple chargers. Some of them already, 2 of them can all together do more than 300. So what we try to do is balance that then at 300 kilowatts for the whole site. So that implies that the grid impact is never exceeding those 300 kilowatts. And then over time, you could, for example, set it to 200 or 400 so that the whole site could take more potentially.
Yeah, so as a CPO, we take responsibility of making sure if we have a 300 kilowatts power supply to a site, we will have the technology solutions, both hardware and software, that it will never exceed that power. So we have the opportunity to do smart charging or balancing or other solutions we may have. First come, first serve solutions. There are all kinds of models we can apply, but we will definitely, we are up for that task, no problem.
And lastly, from a EV driver perspective, if you're driving around packages with an electric van, for example, or I'm driving with 2 small children in the back of my car, I need the charging to get at my destination. So there should always be a lowest case to at least supply a decent service to the end customer, to the EV driver.
Yes, indeed. So that's very important to take into account as well. Another question from Jill Citaria, who will also be presenting tomorrow. It's more about power quality issues. Do you face any power quality issues in practice with having multiple chargers, for example, due to the low frequency emissions or maybe the high frequency emission? Do you have some problems in practice or some challenges you face?
Yes, for example, having 3 different types of chargers on one location, we noticed that certain combination of chargers and vehicles were not working, and it was a really complex puzzle to get understanding that a specific French brand charging on that vehicle would prohibit any charging of any other vehicle on the other charger on the same site. So yes, there are some practical implications from a charge point operator where we face that power quality is impacting actually the availability of charging on site, while the charger is indicating green. I'm available, I can charge. So based on then distortion on the grid. What we also notice is that implementing solar solutions on site with the inverters from the solars creates distortion on the small local high power charging site grid, which also prohibits some vehicles from charging. How that works together is also still not 100% clear. To the end customer and to the market, it seems really logical to combine solar panels and EV charging. But from a practical point of view in our locations, we actually try to get rid of all those solar panels because it impacts the availability of charging to the end user.
Yeah, And to add to that, because that's completely right, we do not. We run into specific requirements from grid operators. For example, somewhere in the northern part of Germany or somewhere in the UK, there are specific harmonic requests. So actually, we need to deliver harmonic investigation reports before we can actually get connected to the grid. So they want to be 100% sure that the equipment we install does meet all the requirements. That is, in our cases, super local. It's always one side within a small area, but it is not a generic request or requirement we see all over the network.
Yeah, so here too, the recommendation would be there's more standardization needed to on international level to make this more generic, to have more generic requirements.
Well, not only that, what we notice is that it depends on the person you come across, even within one specific grid operator, how they interpreted the harmonic reports. And sometimes they're also looking at for example, a peak of distortion at a frequency which is not important for the grid, but just from a power quality point of view, really interesting. Start asking a lot of questions while we are actually trying to realize that location. So there's a sort of a conflict of interest, let's put it that way.
Yeah, and to add to that, what we also see is that for some charges we have a 12 bridge rectifier. So the first 12 harmonics are always perfectly fine, but number 13 is completely out of the bandwidth.
Yep.
So if the grid operators then request reports for the first 9 or 10 difference really, then everything is perfectly fine. But it is sometimes also to specific current levels, right? Up to 63 or up to 32. So there's a mismatch from what the grid operators really request on paper and the reality of our network building. So there is actually much to gain, I would say.
And that's on charger level, and then on transformer level, there's also quite differences in quality of transformers able to cope with the stochastic movement of charging. So most transformers on the market known to grid operators are really used to the domestic use with not as much fluctuation. So not all transformers are capable of coping with that properly, let's put it that way. And we learned that the hard way.
Okay. Thank you both for your comments. I would like to continue the discussion with you, very interesting, but unfortunately we're running out of time, so we are going to close the session. Thank you both for your presentation. Any further questions we will send to you by email, which are still in the question log, and the presentation can be watched afterwards on the YouTube channel as well, so please do so. Next session will be from Enedis EDF by Karima Boukir and Kevin Lorenzo, with also a short keynote of the director, Pierre de la Firmas. So hope to see you there as well. And again, thank you, and see you later.
Looking forward. Thank you.
Bye.
Bye-bye.